All right, the purpose of this video is to walk you through building some of the first digital logic circuits in Multisim. And I am kind of doing this video later at night than normally I'd be in bed by now. So hopefully I can make sense and just be patient with me if I start to, maybe you should watch this and then then do it as opposed to trying to do it along with me, but your call on that. So we're going to look at problems 1, 4, and 7 on this and how we might build these circuits. So we're going to start by placing the source, and we're going to look for power sources. And because we are dealing with digital circuits at this point, we're going to use VCC, which is our digital power. And so for my first circuit, I'm going to go ahead and place that. Then I'm also going to go ahead and place ground. You can use either digital ground or regular ground because ground is ground. And I'm going to place this like a little bit off center. It's not really important for this circuit, but it is good for later circuits. And then pretty much what I try to do is I try to look at all the components that I'm going to need for the circuit, and I try to get them all on the screen at the same time, or at least like if I'm building a really complicated circuit, like I'll get all the pieces for like whatever piece of the circuit that I'm going to be working on. I'll try to put all of those on the screen and then connect them up and then maybe move on to the next part rather than like putting one thing on and then trying to draw like a wire. So I see I've got my 5-volt power, I have ground, I have a switch. So let's go to basic and then switch. So just so you guys can see, I'm going to basic and then switch. And if you looked at the time and it's like 9:17 and you're like, would you really be in bed by 9:17? The answer to that is yes, just in case anybody was looking at when I was recording it. So the kind of switch, what I like about Multisim is that you can click around to find the thing you're looking for. And so when you look at your schematic and then you look at the SPDT, which is your single pole double throw switch, there you can see it's the right kind of switch. So I'm going to click OK. And then it's oriented the wrong way. So if you remember from the previous tutorial, if I hit Control R, I can rotate it. So I'm going to just rotate it before I put it into place there. Then I need some probes and an inverter. So I need 2 probes and an inverter. So I'm going to go to indicators. And we actually use probes in Multisim where we would probably use LEDs. So you can have LEDs in Multisim, but we don't use them that way because a probe does what an LED would do with us do in a regular circuit. So I always pick like just probe green, orange, red, yellow, blue. I never pick the digital probes. I never use them, so I'm not gonna try now. And then because I am how I am, I pick different colored probes because I just like to. So I'm gonna put like a green probe and then I'll put in an orange probe, and the orange probe goes a little bit further down. And then the last thing I need is an inverter. So that's gonna fall under our TTL, and you'll notice some of the stuff from the lesson, like you can pick like the CMOS and stuff, but we're going to go with TTL. And then we want the LS family. So over here on the left where it shows you like all the different families, we're going to go straight to 74 LS. 74 is your TTL, and then the LS is the like low power Schottky. Then we have like everything under creation. Now your activity does give you the number of what you want. So up where it says component, you can go 74 LS, and this is going to be 04, and then you're going to pick the N. I think I mentioned in the audio recording of the lesson that in Multisim, it doesn't matter if you pick the N or the D, just the N is like the dip the dual inline package. So, and then you'll notice here, like you see the schematic, so you'll know that you've got the right thing. And then it says like A, B, C, D. That it has to do with how many of them are in the chip. So there's actually 6 of them that are in the chip, and you're going to default to the first one. And so we'll pick A, and so we'll put that in there. So now I have everything in there. I'll hit close, and then that's just how I like to build my circuits. I like to just get all the stuff on there. So now let's connect the stuff with the wire. So from ground here, and then because that's connected to ground, I actually do want that to be black. So I'm going to right click on the wire, and then it pulls up this, and then I pick segment color. And then this is to power, so I am going to connect that to the red. I'm going to color that red. You can also like change the names of these, and I don't remember, and it's my computer's not letting me go back and look at the handout, like whether or not you want to like change the name of these things. But you can, like, I just double clicked on it, and you can change that. Like S1 is just switch 1, but like you could, you know, call it like switch or whatever. You can also change the key that will toggle it. So spacebar is fine, but if you've got like multiple switches, you'll want to change your toggle keys. Toggle just means to flip the switch. So you can like click on it to flip it, or you can assign a key on your keyboard to do it. So now it's switch. And then we have a wire running there and a wire running out here. And then remember, like, you can't really run this. So you got to run it the other way to get that junction there. And so that is my first circuit. So now to test it out, we're going to run the simulation. So that little green play button right there, we're going to run that. And then you'll notice that both of my LEDs went off, and then this one came back on. And so notice when the input is low, so when this is 0, the output is high. Now to flip the switch, I can just click on it with my mouse, or I can hit the space bar on my computer, like either or. And that flips my switch. And then notice when my input is high, my output is low. And so the function of that particular gate there is it changes the value. And so I can hit my space bar a couple times, and you notice that when the first one's low, the second one's high, first one's high, second one is low. And so what you need to do on your worksheet is you're going to fill in like the 0 and the 1 for the input. So the input could either be 0 low or 1 high, and then the output is the opposite of whatever the input is. Logically speaking, this is like, it's called a negation in mathematics. In engineering, it's called an inverter. And like, it's kind of like saying like this class is in room 506. Which is a true statement. This class is not in room 506, which is a false statement. So it negates the truth value of the statement. So that's what number 1 looks like. Then I thought we would do number 4. So I'm just going to slide my board up. I have to go stop the simulation. I'm so bad about doing that. All right, and let's build the second one. You can build multiple circuits on the same like worksheet. That's fine. Or you can open up a new one. Just be mindful of like saving stuff. Like make sure that you do save anything that you're midway working on. Like don't delete anything until you are 100% sure that you are done with it. So let's go ahead and get our power. If you do your power later in the circuit, just as fair warning, it gives you like this weird warning on it. Okay, so this time I'm going to actually stagger these more intentionally because you'll see what the wiring is going to look like. Now I need 2 switches. And switches are under basic. And as you make your circuits, you will get so much more comfortable at where you find certain components. Like you'll just get so much more comfortable with it and really fast. At first, it's like, where do I find all this stuff? So we want 2 switches, and they do need to be oriented the other way. So I'm going to flip them before I lock them into place. And I need another one. And that is not the best. Okay, I'm going to rearrange that. Now I need 3 probes. So I'm going to go to indicators. There we go. Indicators. You can also find that across the menu at the top. What haven't we used? We didn't use red. So let's put a red probe. We're going to have a red probe like right about there. And we'll put a yellow probe just to make it pretty. And then our last probe, we haven't used a blue probe. So now you've seen all of the different color probes. That's great. And we need a 74 LS 32 is what we're looking for. So I'll go ahead and type that in, and that should match the schematic that you're looking at. And we'll get that on there. Oh, we're going to use, that means there's 4 of them in the chip. Okay. Looks pretty good. And we're done. Now they did a couple things on the labeling, and I didn't label the first one. I'm sorry for not doing that, but you can change the names on the probes so that like you know what they represent. So I'm going to make this one X, and then this one is Y. And what I'm doing is I'm just double clicking on them, and this one is Z, like our output. And again, we have like low and high on that. All right, and I wanted to move this down. Now, if you want to move a component, when you click on it, make sure you get like the big box on the outside. Sometimes if you click too closely, it will like you'll just highlight part of it. Like if I just click on that, like it doesn't give me the whole thing. Now we might want to change the toggle keys, because right now, like both of those, like I'm hitting my space bar, like they're going to toggle at the same time. And so I might not want that. So we'll make this one toggle with the A key, and we'll make this one toggle with the B key, just so we have A and B. That way I can press A and it only toggles one of my switches. All right, so let's get this puppy hooked up, shall we? So we've got power, and we're going to run power to the top of each switch. And notice like I do have to grab it from down here, and I'm okay with that being in red. And then ground goes to the bottom of each switch, but I don't really want ground in red, and it's behaving as giving it to me in black, so that's good. And you just kind of want to keep that in mind, just like your red and your black there. Now, both of those inputs are going to go in, or the switches go into my gate over here. So there go my 2 switches. Let's zoom in a little bit. There we go. That's a little bit better to see. And then the output goes to this LED or probe, but it's like a little light. It basically just tells you whether it's high or low. Like the little light will go on if it's high. Now these 2, the first one is connected to the first switch, and then the second one is connected to the second switch, like that. And honestly, as you build circuits, you're going to develop like a style for how you design them, how you put them together. And I did my training for 2 weeks, and I got so much better at just like my own personal style of doing the circuits. Like I would color the different nets and pieces of the circuits. I got better at when you have like a lot of inputs and you got to like invert them all, and you have like kind of a mess, like organizing the wires so they don't overlap everywhere. And all of that just comes with experience. So now we're going to fill out the truth table. So I'm going to come up here and hit the little green button for run. And right now, what do we have here? Both of the switches are on. So I'm going to toggle them both to off. So what that is they're both connected to ground. So if you look at that first switch, it's on the low voltage. So it's on ground. You'll notice that the little probe attached to it is also off. And then the second switch is also to ground, and you'll notice that that is off, and then the output is off. So the top line of your truth table would be 0, 0, 0. Then you want to methodically go through your truth table. So the next item in the truth table is 0, 1. So I need this one to stay off and this one to turn on, which means I have to flip the bottom switch. And so when I do that, this actually turns on. And so the second row would be like 0, 1, 1. Now the next line is the first one is on and the second one is off. So I'm going to go ahead and toggle the second one off and then the first one on. That is not right. That is not showing. Why isn't that probe showing? That should be on. What I'm doing is I'm zooming in to check the connection to make sure that, but it was like on before. That's a malfunctioning probe. I'm going to turn the simulation off and then turn it back on again. That's wrong. Yeah, because when you have 0, 0, when your inputs are 0, 0, the output is 0. When I turn that to on, this should be on because it's connected to power. And I have never seen this happen before, ever. I'm going to, I'm actually going to delete that and I'm just going to try replacing it. And there it goes. Okay. All right. I don't know what was going on. Okay. So there we go. When it's 1, 0, then the output should be a 1. I'm just gonna rob me of sleep tonight. It really is. And then the last one should be 1, 1. So I'll go toggle that on. And when they are both on, the output is high. So we have 1, 1, 1. And so that should help you fill out your truth table. So like when this switch goes, why that wasn't working. Like, so when it's high, it should go on. When it's tied to ground, it should go off. Like now it's working fine. And the same with this one. You should see that little probe kind of go on and off with that switch. And then when they both go off, that's when the output goes off as well. So there's that. Now, the last thing I wanted to do, and I'm sorry this video is long, but I hope it's helpful, is I wanted to like jump down to further in where you actually are going to be dealing with a flip-flop. Because the circuit is different. I just want to show you how you go and like find the stuff that you need for your flip-flop. So for this one, make sure I turn off my simulation. We need VCC. They actually have VCC in 2 places. They have it over on the left, and then they have it again. Now, like reality, when you were like building this circuit, you would have like they would just be tied to like the same high power rail on your circuit board and stuff, but for the like cleanness of your schematic, like you don't want to be running wires like all the way across like your page. So you just kind of put an additional power source near where you wanted it to be. And then we have ground. So I'll go ahead and put ground down here. We need our switch. So the switch is under basic. Oh, just so you guys remember too, you can get these across the top. So source, there's basic. Then we have TTL. So if you need to like just go straight to the TTL stuff. CMOS, then we have the indicators. That's where you can find your probe. And I think like there were some other things that you can find up there. So what was I going for? Was basic. And we're still on that single pole double throw switch. This time we only have one. And I'll hit Control R, flip my switch around. Now I need 4 probes and a flip-flop. So let's go find the indicators. So let's go grab those diodes. We'll just go with a bunch of blue diodes. I'm going to put them over here for the moment. We'll just kind of put them over there. We'll move them when we're ready for them. And then the last thing I need is a flip-flop. So you go pull up TTL, and then they give you the number that you're looking for. So 74 LS 74 N, and that should match. We're going to use A. That should match the schematic that you see in your handout. And that's all we want. And I think we got everything on there. So we are going to wire up this switch to power and to ground. Okay, so pretty much like it's kind of, we're just turning the switch on and off. Then that switch runs into the CLK, that is for clock on your flip-flop. And then one of these probes, let's go ahead and move one of these probes over. And that probe connects to this clock line. And I'm going to go ahead and change the label on that to clock. Okay, and that way when I'm looking at that LED, what I'm seeing is like, is the clock pulse going high or is the clock pulse going low? It just tells you what it's going to do. And probably your intuition is just going to tell you like when the switch is thrown, it's going to go high and then it's going to go low. All right, where does this VCC go? This VCC goes to 2 different places. It goes right here, and that is your reset. And it's like, it's active low. So we haven't talked about this, but those little circles mean that it's going to reset when it's low. And then it's also going to come down here to the clear or preset, sorry. And then it's going to clear when it's low. So by tying those to a high voltage to your power supply, it means it's never going to clear itself. So you're taking away the capability of that clearing itself. Then what do we have? We have the outputs from this pin, and it like loops around. And I see if I just do this, I don't know. Yeah, well, I guess that's okay. I kind of want to give it a little bit more space over there. And so what I did was I just clicked my mouse to kind of get a little bit more space over that. Then we have a probe that goes, let me drag this over, that goes right here. And that one is called data in. So we'll call that one, here we go, that's data in. Oh, labels cannot contain delineators. There we go. Data in. And then our last 2 probes, let's kind of bring these puppies down. So one of them is tied to the output Q, And then this one is tied here. So like a lot of this stuff with the flip-flop, you don't know what it does. And that's part of the investigation, is to figure out what a flip-flop does by looking at the switch. And then like what happens when you throw the switch. And what you want to watch is you want to watch like the data in and the clock. And then what does that mean for these two and how they're related to each other. So let's go ahead and start the simulation on this one. So everything started out low. Okay, it took a second for that to catch up. So we have a low clock pulse. So this is sitting at 0. And this not Q is sitting high and Q is sitting low. People that had taken that dual enrollment class will know what that symbol means. Not Q and then Q. So let's flip the switch. Okay, and what that did was it basically flipped the outputs. So now this one is high and this one is low. And you can see the clock is high, and now we'll make the clock low again. And notice that nothing changed over there. And so you probably thought like, oh, every time you flip-flop, like every time you do the switch, it's gonna flip-flop the stuff, and that's not what happened. And then we'll make it high, and now it flip-flopped. Okay, so clock is high, and now we're 0, 1, and I go down low, and then nothing changed. And then I go high, and they flip-flop. And then it goes low, and nothing changes. And then it goes high, and okay, so you probably get the idea that with a flip-flop, you have it tied to some kind of like a clock. And this is what's called a positive edge trigger, but it causes like the values to flip-flop, but only when the clock goes from low to high. Making the clock go from high to low doesn't change the output. And so only when you're flipping the switch in that direction do you get any kind of change. Now, I don't remember what the questions were on that one, but hopefully that gives you enough guidance so that you're able to answer it. And I think this video should have showed you enough about where to find the components, how to place them, how to like structure them so that you are okay for doing the rest of the circuits on your own. I apologize for taking, well, it took me about a half an hour to do it. And I don't still know what happened with that switch on that second circuit there. That was really weird. And let me know, as always, if you have any questions about the content here.